$2,960. She liked both cars, but then she began to think about the cost of owning an older car, so she decided to ask her mechanic about problems she might face with the maintenance of the auto she chose. Mel mechanic told her that the Rambler would average $150 per month in expenses, but that the Mustang would operate on $60 per month in expenses. In expenses.
Okay.
And then
What was the original cost again?
the original cost for the first car was 1,250.
That was the Rambler.
Yes,
Okay.
I don't know if that's a real car.
Yeah, it is.
Uh, it's and then the next one was 2,960.
Okay, so what do they want to know when it costs less to have the Mustang?
Says find the equations of these functions.
Okay.
So it
So
would be y, which is the cost.
hmm
Well, it says to do it in R of t. So like
okay.
total cost of time,
Okay.
and then it wants the x as t. So the rt equals it would be the average expenses
hmm
150t, and then plus the original price, which was
Good.
1,250.
Yep. And
And
MT
then
would
yeah,
be
mt
60.
would be
Okay.
yeah.
And then what? So
It
what do they
says
want
to
to do?
find r is R25 and M25. So just
Okay.
plug 25 into the equation.
Good. You can do that, right? You're good with that?
Hmm.
And then what else does it say? That find out at how many months it would be
Just
cheaper.
find the break even point, explain its meaning.
Okay, so do you understand what break even point means?
I think it's when the one function becomes more than the other.
Right. So you can tell that this is going to start lower, right? The red graph, but the slope is higher. So it's going to look like that, right?
Yeah.
And then the other one, let's call it blue. The Mustang is going to start at a higher cost.
Higher, but then go slower.
Yeah, so you want to try to find that point right there. And how do I find that point?
I forgot.
So this is where you could either use your graph and find it with your graphing calculator. If you just can, use the plotting and find the intersection point, or you can set them equal to each other, set the two equations equal to each other, because that'll be where the y's are equal to each other, right? The y values, the f of x values.
How
They're,
would you do that?
so just set these equal to each other. M of t and r of t are equal to each other. That's probably the easiest way to do it.
All right, got it.
And then solve it for t, right? So subtract 60t from both sides, that'll give you 90t. Subtract 1250 from both sides, that'll give you 1710. 296, yeah, 1710. So t equals 171 over 9. And you can tell, this trick, that 171 is divisible by 9. Because if you add up 1 plus 7 plus 1, that number is also divisible by 9. That's one of the divisibility rules for the number 9. So I know that's going to be a nice number. Let's see, 9 goes into 171 19 times. So the number of months that for the break-even point is 19. And then if you plug 19 into either one of those, you'll get the same answer out, whatever that happens to be. Which they may have asked for that as well, right?
They just asked for the break-even point and to explain this meaning.
Yeah. So the explanation would be
When the Rambler costs more than the Mustang.
the same amount as the Mustang. Break even is the same amount. So if you were to own it less than 19 months, it would have been cheaper to have the Rambler. And if you were to have had it for more than 19 months, it would have been cheaper to have the Mustang.
All right.
Got it?
Yep.
What else you got?
All right. So this one's just how many solutions does a quadratic have if the discriminant is greater than 0, and that's 2 real solutions.
Yep. If the discriminant is equal to 0, what is it?
It has 1 solution on the x-axis.
Good. And what if it's less than 0?
2 imaginary.
Good. Yep. Good. What else? By the way, I am recording this on YouTube in case you want to go back and look at it.
Got it. All right. This one says, what types of solutions will we have if the discriminant is a perfect square? I think that means that they're perfect squares, right? That each solution is a perfect square.
No. If the discriminant is a perfect square, that would mean that think about your equation, negative b plus or minus the square root of b squared minus 4ac. So if this thing was all over 2a, if that thing was a perfect square, you could take the square root of it. Right?
That would make it a whole number.
That would be a whole number, correct? That would be a whole number, but that would make this entire thing a rational number.
So just they're rational numbers. Okay.
Yeah, 2 rational solutions. That's what that means.
If the discriminant is not a perfect square, then it can be 2
Irrational.
solutions. It has to be irrational.
Yeah, it would be, well, if it's not a perfect square, but if it's still positive, is that what they mean?
It just says if it's not a perfect square.
Well, negative numbers can be not perfect squares either. So what you could say is if it's a positive number, then there would be 2 irrational solutions. And if it's a negative number, then there's 2 imaginary solutions. And I suppose 0, I don't know if they're considering 0 a perfect square or not, but if they are, then maybe, if they're considering 0 a perfect square, then we have to change this to 2 rational solutions or 1 solution.
I don't think so.
0.
Probably not.
Well, yeah, you kind of have to be careful because they're really not being too careful about what they're saying either. So anyway.
So if it's positive 2 irrational, and then if it's negative 2 imaginary.
Correct.
All right, and then it just says again if the discriminant is greater than 0 or less than 0. Greater than 0 has 2 imaginary solutions. Oh, wait, no, greater than sorry,
2 real. Yeah.
Greater than 0 is 2 real. And then if it's less than 0, then it's 2 imaginary.
Correct.
Ugh. All right. All right. Sketch the graph of negative x squared. All right, so sorry. Sketch the graph of y equals negative 2x squared plus 2x plus 12. So
So factor out a -2. That would be x squared minus, minus x minus 6, right? So that factors into -3 and +2. Got it. That's the best way to do that. So watch how quick this is if you have it in factored form. 1, 2, 3 is one of your zeros, 1, 2 is one of your zeros, and it's going down. So it has to be, it's got to be going down like this. So I can also find my y-intercept, which is right here, +12. So it's way up there. So your graph's going to be the vertex is going to be at perfectly between these 2 points, right? So it's going to be at 1/2. Get how I did that?
Wait, what?
The vertex is going to be at x equals 1/2 because it has to be right in between. It's symmetric.
Yes, okay.
I didn't make that a very good looking graph, but
Oh well. So
like that.
This goes by twos.
Got it.
And the vertex is what again?
So the vertex, they didn't really ask me for the vertex, but it has to be above 12.
Yeah.
And it is got to be right in between the points -2 and +3. So right in between those points is +1/2. So that the x coordinate of the vertex is 1/2. So you just know that it's going to be a little bit higher than 12 because of that 12 is the y-intercept. See what I'm saying? And it's just got to the right of that a little bit, and that's got to be a vertex. So it didn't ask me for the vertex, so I'm not.
It did actually.
Oh, it did. Okay, well then just plug in 0.5.
I think it wants me to show like how you get that, like with the equation. It's negative b over 2a, right?
Yes. I was showing you something that another way to find the vertex. If you have your two x-intercepts, you can just find the midpoint between them, and that'll be your vertex. That'll be the x-coordinate of your vertex.
And then you just plug that in to get you that, yeah. And then the axis of symmetry is just x equals 1/2. And sorry, y equals 1/2.
Yes.
And then the point
No,
symmetric to the
actually, no, it is x equals 1/2.
oh, yeah, right. And the point symmetric to the y-intercept would be 112, right?
Perfect. Good. Yeah. Which I didn't do a very good job drawing. My graph's a little bit off, but yeah.
All right.
I just didn't do a good job drawing the graph at all. So I didn't take very much care. Okay, good.
So the y value for the vertex, what was that?
Yeah, so you got to plug in 1/2 in for x in all these places. So that would be -1/4 +1 plus 13. So it would be 13 3/4.
Wouldn't it? Well, the negative two at the front, wouldn't that make it positive one? I mean, wouldn't that make it negative 2/4 instead?
Actually, sorry, 1/2. That would
Yeah.
make it -1/2. Yeah.
So then it would be 12 and 2/4 or 12 and 1/2.
Correct.
Got it.
No. Oh yeah, this was 12. Yeah, not 13. My bad. Yeah, 12 and a half. Correct. Okay, good.
Yeah, just need to put it on there now. Yeah, all right. All right. This next one's a word problem again.
Okay.
A swimmer starts a race on top of a 2.5-foot starting block. The race
Okay.
starts and the swimmer enters the water at a distance of 5 feet. The swimmer eventually comes out of the water for the first time at 31 feet. Find the swimmer's maximum depth and at what distance this happens.
We're assuming it's a okay. So he starts here at 2.5. So that's the x, that's the y-intercept, 2.5. And he goes up in the air. I'm assuming he goes up in the air and it comes down, right?
Uh,
Well, maybe he's just going.
yeah.
You said he enters at 5 feet and comes up at 31 feet.
Yes.
Okay, so that's 26 feet is the difference there. Okay, and what do they want us to do?
Find the swimmer's maximum depth and at what distance this happens.
Okay, so the assumption here is that it's a parabola. I mean, I don't know how you could assume that, but
Yeah, it's weird.
apparently they want you to assume that. So my points are going to be, I've got a point of 0, 2.5.
And I guess that means that it would go into the negatives for a bit, just to show that it's like going underwater. 0 would be like water level.
Yeah, 0 is water level. So that's what's happening right there. It's doing that, is what I'm assuming they're saying. So, like we talked, like I was mentioning you before, the halfway point between these two, assuming it's a parabola, that halfway point, so 13 feet away from 5, so at 18 feet basically is your, at the point 18, that's going to be your, the x coordinate of your vertex, right? But we also know that the equation follows this. It equals a, some a, we don't know what a is yet, and then the two x coordinates are 5 and 31, right? Because this point right here is 31, this point here was 5, and we don't know what a is, but we can find a by using this point right here, plugging in 0 for x. We know we'll get 2.5 for y. So that's what we do. 2.5 equals a times -5 times -31. So 2.5 divided by 5 and 31. 2.5 divided by 31 times 5. That's some crazy number. It's like, I'm just going to write it like this. 5 times.
Oh, the numbers are weird in this.
Yeah, I mean, again, I'm just assuming that that's what we're dealing with here, but you're going to get some weird number for a, right? And then to find out what your depth is, that's what they said, the depth, plug in 18 to this equation right here, plug in 18 to those and plug in that a value for that too. So I'm going to take that number and multiply it by 18 minus 5, which is 13, and then 18, multiply that by 18 minus 31. So negative 2 point, that value,
Whatever it is.
negative 2.73 if you round it. Okay.
All right.
All right. I got my next guy here, Vincent. Okay.
All right.
So good luck. I'll see
Thanks.
you. Am I gonna see you tomorrow?
Yes.
Okay,
See
I'll
you
see you
then.
tomorrow. Bye
Goodbye.
bye. All right. What's up, Nor? How you doing, bud?
Good, how are you?
Good. I'm still just gonna keep recording it from what I had before, just so you know. So go to 25 minutes in and you'll see it. So what we got today? You got some questions for me?
Yeah, just trying to help understand because, well, I was basically what I've been doing the last week and a half
Mm-hmm.
is reviewing my past online chapter reviews
Okay.
and just redoing all those questions. But
Sure.
I've came across some questions I don't remember doing or I don't understand how I got it.
Okay. So I'm to the right of what I was just doing. If you want to
Okay.
put your questions in there, usually you do a pretty good job putting the questions in. The average rate of change. Can you remind me what class you're in?
Honors pre-calc?
Okay. Yeah, because calculus is different. Calculus does these things different.
Okay, calculus has a different way of solving these.
Yeah.
EP.
Yeah. So the rate of change just means, so if I take this graph, right, this is just a parabola, right, opening up,
Yeah.
and it's at 6, going through at 6, and it's something like this, right?
Yeah.
The average rate of change just means um, between -2 and 0. So -2 would be right here, and 0. So this rate of change right here, the average rate of change would just be finding the slope basically between those 2 points. So take those points, plug in -2, and you're going to get -2 squared is 4. 4 times 3 is 12, plus 6 is 18, right? And 0 comma 6, right? So
Yeah.
the average rate of change between those.
Is the slope.
This is the slope. So 18 minus 6 over -2 minus 0, which is 12 over -2, which is -6. So that's your average rate of change. And then you can do that's for A. Do that for B and for C as well, for the different numbers.
Okay.
Got it? So just find out what those points are.
Okay, so let's just find the slope between the 2 points. Oh,
Yeah.
got it. Now I can see how that works.
Okay. Good.
Yeah.
You can do the other two, right?
Yeah, I can do the other two after. Um I got another question.
Yeah.
I'll put this right underneath.
By the way, what are you doing to get to copy and paste those things? What are you on a computer?
Yeah,
Okay. Other people just have a hard time doing it.
strange.
Yeah. You're just copying, you're just taking like a screenshot of it.
Yeah, I feel like
That.
on phone, this is Zoom, right?
Yeah.
So when on a whiteboard, when they're asking you to add an image, there should be like an option that says like pick image from where, files, gallery, and other options. And I feel like that's how it would.
Yeah. You're just taking a snip or whatever. You're just taking a screenshot of
Yeah,
the computer and then putting it. Yeah.
yeah.
I don't know. Some people maybe just don't have the ability to do that. All right. Determine algebraically whether it's even, odd, or okay. So even functions follow the have the following: f of x equals f of -x. Those are even.
Mm-hmm.
Odd functions have this quality: negative f of x equals f of -x. And neither don't have either of those.
Okay.
Okay. So what we're going to do is we're going to find out what f of -x is. So f of -x equals -6 times -x squared minus -x.
That
which
would be
negative
neg
6x squared plus x,
yeah,
right?
which is different.
So it's not even, right? Because f of x would have to equal f of negative x if it was even. Now
Hmm.
let's find negative f of x. So that's negative
Over everything, over
f
the
of x.
f
So
negative x.
yeah, so both of the signs change. So is it?
Wait, how did so
Because you
for
distribute negative in.
yeah, well, the even like the end part was negative 6x squared plus x, but down it went back to a negative 6x minus x.
Yeah, because look what I'm doing. Negative f of x. This is f of x.
So we're taking it back from the parent. It's just that on the
Yeah,
right
yeah,
side,
yeah.
you were doing negative fx equals f of negative x. So I
Yeah,
thought,
you have to calculate them both. Calculate negative f of x and to calculate f of negative x. Calculate them both and see which one, see if they're equal. You basically have to calculate all three of these. They already give you this. You have to calculate this, and you have to calculate this and see if any two
okay,
of them are equal. And if
and
none of the two of them are equal, then it's neither.
so like for this one, it's negative 6x squared plus x, and the other one is 6x squared plus x. The six are different, so this would be neither, right?
Right. It's neither.
Okay. Okay, so it's not that bad. Just substituting negative x first and then negative the whole equation.
Yeah.
Wait, so with odd, do you check th- with the parent or do you check with the f negative x?
You check them all.
Oh, okay.
Calculate all three of them. Well, the one you don't have to calculate f of x. They gave it to you already, most likely. But then you have to calculate negative f of x and f of negative x. So let's take another example. X squared plus 3. What kind of function is that?
This is a quadratic.
Right, but is it even, odd, or neither?
It's even.
It is. It's even because f of negative x also equals x squared plus 3. And by the way, one of the reasons that you know it's even, well, one of the other characteristics of an even function is it is symmetric to the y-axis. So you know that that graph is symmetric to the y-axis.
Mm-hmm.
But one of the other characteristics of an even function is all of the exponents, if it's a polynomial function, all of the exponents are
Have
even or a constant.
okay.
Whereas if you had f of x equals 3, let's say 32x cubed plus 15x, is that even, odd, or neither?
That would be odd.
Good, that's odd. How about if you had f of x equals 32x cubed plus 15x plus 3?
Wouldn't that still hmm. Would that still be odd?
No,
Because the
that's neither. The
neither?
reason that's neither is because you can't have a constant in an odd function. You can't have a constant like that in a polynomial.
Oh, okay,
So this is neither.
okay.
But you also have functions like y equals cosine of x. Do you know what cosine of x is?
The cosine is the it's the next to the angle
Yeah,
over
but think about what the graph looks like. What's the
oh,
cosine? What kind of graph is that? Even, odd, or neither?
this would be it's not even.
It is even.
It's even.
Yep. Whereas the sine function starts here and goes. So it's symmetric to the origin. So odd functions are symmetric to the origin. Even functions are symmetric to the y-axis. And so cosine of x is even, sine of x is odd,
Hmm.
which also explains why the negative sine of x equals sine of negative x. That's a trig property that you hopefully remember.
Yeah.
Also, that explains why the cosine of x equals the cosine of negative x, because it's an even function.
Hmm. Okay. I think probably in calculus they'll go more into the even and odds of cosine and sine because my teacher hasn't talked about these, but it's good to know.
Yeah,
Hmm. Okay. So from what I've seen is if a function has a constant or the power is an even, then the function is even. But if the function the x are powered by an odd with no constant, it's an odd.
yeah, and you can't have both. You can't have some of each. It would just be neither if you had some of each.
Yeah, so if
They
there's a
all have to
x.
be, yeah, for polynomials, they all have to be even or constant for an even, or
Hmm.
they all have to be odd and no constant for an odd one.
Hmm. So a 32x cubed plus a 15x squared would be neither.
Yes.
Okay,
Okay.
that's good to know. Um, I have another one.
Yeah.
Just trying to look for the one that I might need most help with. Um, sure, this one. Oh, I put it next to the first
Yeah.
one.
I got it. All right. So
I made it math.
this would be um this interesting one because of the way that it is. So what I would do for this one is I would imagine plugging in, dividing everything by um, multiplying everything by um, 1 over x squared to the fifth power. So
Hmm.
multiply that entire thing by that. In other words, divide all the things on the inside, divide them all by x squared. And what would you get? You would get 1 plus,
Oh,
or whoops, sorry, 1. Why is my pencil so thin right now? I don't like that. 1. Oh, that's better.
it's very thick now.
Now it's a little too thick. Okay, let's try this again.
I
It's very,
think
it's
I,
being
I
really touchy too.
I think the reason it's looking thin is because the question I made is bigger than everything else.
That could be. I don't know. That's okay. Um, so it's 1 minus x squared all over 1 plus 7 over x, right?
Wouldn't the one on top also be one
Yeah,
over x
sorry.
squared?
1 over x squared. Yeah, thank you.
Okay.
Right. So if all of these things are going to negative infinity, then this is going to 0. This is going to 0.
Mhm.
So the whole thing is going to net,
Zero?
and see that negative there?
Yeah.
That negative, since it's a negative infinity, but squared is going to be a positive number. So it's still going to be a really big negative number, like negative infinity
Hmm.
over 1. So the limit is negative infinity or just does not exist. I don't remember what he wants you to put, what they want you to put. Do they want you to put negative infinity or does not exist?
Um, Let me check. Um, I think it was chapter 14. Let me go. Chapter 14. I've them all written down on my notes on paper, but tab wise, it's hard to find it because I have so many tabs for math.
Do you have
7.
do you have your do you know the answer key for this? Do you have the answer key?
This was not a worksheet that came with the answer key, and I'm checking back on the question, and for whatever reason, it's blank. So I didn't even solve it, but I'm guessing it would have been negative infinity.
Okay, well let me plug in the you could also plug this function into like Desmos or something and find out if you and then look at where it's going as you're going to the left. You know what I'm saying?
Yeah. I think. Hmm.
So I'm gonna do that real quick just to be sure because I don't remember seeing this problem before yet.
I do think negative infinity is the right answer because what I'm doing is the website generates also similar questions if I want to. So I'm clicking similar questions and I'm putting negative infinity as the answer and it's saying correct, correct, correct. So I think the answer is negative infinity.
Okay. Y equals, let me see if I did this right. Negative 1 over x squared, all raised to the fifth. Yeah, for some reason on my the graphing calculator I have, it's not doing a really good job showing.
Mhm.
It's actually looking more like positive than if you're plugging in numbers, you're getting a negative number, you're going to get a really large negative number on the top and a not so large negative number on the bottom because they're going to be canceled because it's the fourth. So let's see, negative and then to the odds. Yeah, it should be negative, but
Yeah.
just for some reason the graphic calculator is not showing it very well.
Yeah.
I think if there's another way you could algebraic it. Just,
Okay.
I, did your teacher teach you like to look at the leading coefficients? The problem with this is you don't really know what the leading coefficient is because I don't think you can just look at these things.
Yeah.
You know what I'm saying? I think you have to consider the fact that it's being raised to a fifth power.
hmm Yeah. I'm gonna ask him about this question tomorrow.
So, oh, you know what I forgot to do? This was all raised to a fifth power. So it's still negative infinity raised to a fifth power,
Wouldn't that still be negative
which is
infinity?
still exactly, which is still negative. That's what I was getting at. So, yeah.
Yeah.
Do you have Desmos?
I have access to Desmo, yes.
You could also just plug that into Desmos and take a look. As x gets further, go to the left, plug that function in for y equals, and then see where it goes as x goes to the left toward negative infinity. All right.
Yeah. Um, I know that it's a little bit over, but can I ask you this
Yeah, you got
one
time.
more question? Like this
Yeah, go
question's been
for it, bud.
annoying me for a
No problem.
while.
No problem. Divide numerator and denominator by the highest power of x in the denominator and proceed from there. Yeah, this is what I was telling you about. What I was just showing you, what I was demonstrating. Divide numerator and denominator by the highest power of x in the denominator. That's what I just did on that last problem. And
Mm,
proceed from there, find the limit. So they're telling you, so this is tricky though because it's all negative. Um, I don't know if that's how I would do this problem. Let me see this problem real quick. Really, this is what this problem is, right?
hmm
I would be tempted to, instead of dividing by the powers, I would be tempted now to multiply because of the way this problem is set up. I would multiply by x to the
6?
sixth. See, if I multiply by x to the sixth, that's going to give me x to the fifth plus x over x to the third minus 1. Now I would divide everything by x to the third. So that wouldn't, so no, we didn't want to do that. So we didn't want to do that. We wanted to multiply everything by x to the third. That's what we wanted. Let's see if that works better. If I multiply by x to the third, I get x squared plus x plus 1 over x squared over 1 minus 1 over x cubed. Right?
Yeah.
And so now if I plug in the value, if I plug in infinity, this goes to 0, this goes to 0, and I have x squared over 1, which is just infinity, positive infinity.
Positive infinity.
Yeah. Now this problem is saying divide the numerator and denominator by the highest power, but what do they mean by the highest power of the denominator? I think what they mean is like the highest power would be -3 because that's higher than -6 because they're both negative.
Mm-hmm.
You know what I'm saying?
Oh,
So it's kind of a weird way to put it.
wording.
What they're saying, they're wording, and they're saying divide it by the highest power. So they're telling you, let's do it the way they're suggesting, I believe. They're suggesting that you divide everything by by x to the negative third. Right? That's what they're saying. So you would get x, that maybe this isn't the way to do it. I just wouldn't have thought to do it this way. You would get x squared plus x to the -2 all over 1 minus x to the -3. You're getting the same thing that we got here.
Okay.
I just don't like the way that they're wording it. It doesn't make sense for me to do it that way, but whatever. Same answer. Answer's infinity.
Okay. Okay.
Make sense?
Yeah, it makes much more sense than before.